The pool bottle magic that I played in the lessons are actually making use of redox reactions. Redox reactions are very common in our daily life. For example, the reactions that we discuss in chemical cells are making use of redox reactions. In this chapter, we will talk about the definitions of redox reactions and how we can write a balanced equation for redox reactions. From the name, we know that redox are coming from reduction and oxidation. RED stands for reduction and OX stands for oxidation, combining giving the redox the name. So that's why in a reaction there must be reduction and oxidation occurring together in order to give redox. So let's talk about what is oxidation. From the name oxidation, the definition that very obvious is in terms of oxygen. That will be adding oxygen to something. We call it oxidation. For example, if we look at example 1, copper oxide adding carbon to give 2 copper and CO2. Then from this reaction, carbon has add oxygen. Okay, for copper, you have lose oxygen. Okay, so that's why we call carbon is oxidized to CO2, or we say that CuO oxidizes carbon to CO2, or we can say that carbon has undergone oxidation. Okay, so this is how we define oxidation. But sometimes it is very difficult to use the definition of oxygen because there is no oxygen transfer in the reaction. Just like example 4, here we cannot see any oxygen atoms in the reaction. So that's why we need to use another definition. For example, making use of electrons. Here zinc has lost 2 electrons to become zinc 2 plus. So zinc loses electrons in this reaction and we call it oxidation. Okay, so zinc has undergone oxidation. So you may wonder how when we should use the definition in terms of oxygen and when we should use the definition in terms of electrons. The answer is you can choose whatever definition that you want, which is convenient for you to judge whether that reaction is redox, because they are complementary to each other. Let's say if I have a potassium oxide, so potassium oxide K2O, if you draw the electron diagram, we have 2 potassium and then oxide, you have okay, so you have this electron diagram. So in a reaction, if potassium react with oxygen to give out the potassium oxide, then potassium has gained oxygen. But whenever it gains oxygen, since oxygen is an atom which wants to gain electrons, so at the same time it loses electrons to oxygen atom as well. So that's why both definition in terms of oxygen and in terms of electrons are complementary to each other. The third definition to define oxidation is in terms of oxidation number. Because some reactions may not have obvious observation for the oxygen transfer and electron transfer, so we may need to use oxidation number to help us easier to observe whether a reaction is redox or not. We will discuss it later in page 2. So let's look at reduction as well. So since reduction is just the opposite of the oxidation, so we can define reduction in terms of oxygen by addition of oxygen. For if it is in terms of electron, it is addition of not addition of oxygen. It should be loss of oxygen. And then for electron, it should be addition of electron. So in terms of oxidation number, we have if whenever there is decrease in oxidation number, then we can define it as redox. Define it as reduction. Right, note that whenever there is something lose electrons, that means having oxidation. Then there must be something that accepts electron, which is having reduction. Right, so that's why we call this kind of reaction redox. Right, we must have reduction and oxidation occurring together. So let's look at some more example. So when you look at the second example, zinc oxide reacting with hydrogen, then zinc oxide has loss is oxygen and H2 has gained oxygen. So according to the definition loss of oxygen, that means having reduction. Then at the same time, we have hydrogen having oxidation. Right, so that's agreeing what I have just said. Oxidation and reduction must occur at the same time. So for magnesium, it has gained oxygen, and oxygen you have it has lost oxygen. So gain oxygen, that means oxidation. For oxygen, it undergoes reduction. So for the last example, magnesium has lost electrons. So lost electrons, that means oxidation. And then for hydrogen ions, it gains electrons. Hydrogen ion, it gains electrons, so that's why it is reduction.